Good afternoon, everybody, or morning, or whenever you are deciding to watch this video. I'm going to be taking a look at the radar from the June 28th, 2018 convection from St. Louis from the KLSX radar. And what we're looking at here is a Boeing segment of precipitation, and we're going to do an assessment of using the volumetric scans. So the cross-section mode and the volumetric mode on GR to kind of get an idea of how this system is behaving. And so I think this has been correctly identified by Kenna Mitchell, that this is indeed a bow echo. As you can see, there's it's a Boeing segment of precipitation. There's a pretty good convergence in the velocity product. And I set the storm motion to 306 at 44 knots to kind of see what's going on with the storm from the storm's perspective. And so note and see if we can note any of these any kind of bookend vortices or anything with this system. You can see we do have some trailing precipitation, so this is a very cold pool driven system, and it looks like it's kind of traveling right along a boundary, because if we go through, you can see that there's some convection firing up along a line that extends through southern Illinois. So without further ado, we're going to look at the volumetric scan of this event and see if we can notice anything about these thunderstorms. So I'm going to do a pretty broad picture of these, and I'm going to bring this over to my screen for viewing. And so the first thing we kind of notice about these storms is that the cells are pretty much, and this is I'm looking at an ISO, so I'm just taking out the I can put this down here. I'm just looking at the kind of the highest DBZ values, but we can slide this over, and we notice that these are pretty vertically stacked structures. So that being the reflectivity values in the image are pretty vertical. They're not tilting in any sort of way. And that makes sense, because as we kind of move through the loop, the cells kind of build up and fall down. They kind of bubble up and fall down. So there's not a whole lot of tilting to support updrafts. As this cold pool generates the lift, or acts as the triggering mechanism, there's nothing to really sustain those cells other than just the convection around it. So they bubble up and they go down, and you don't have a very large supercell development out of the structure. And that being said, it is still producing quite a bit of strong winds, it being the cold pool driven cell, and that's just as the precipitation behind it rains and the cold pool develops, the convergence zone out ahead of it creates those thunderstorms. And then because those thunderstorms lack the support aloft, they collapse real quick, and that creates those stronger winds down at the surface. So bow echo events are severe events, and so we can look at kind of the ISO surface. So I like to kind of block out some of the like to still see some of the weaker returns, but put more emphasis on the higher returns, and you can see the vertical nature of those cells. And then you can see over time as they kind of bubble up and fall down as the bow echo goes through. And then you see as we get closer to the radar's to the south, down there's the cone of silence. You can see you start to pick up on that lower level outflow boundary developing on the radar. So, and that's the last loop of this particular cell. There's also, and this might be along where the boundary is actually located, but the development of the convection ahead of the actual bowing front, and this is actually, it might actually be traveling along that along the front, as they often do. So, all right. And our cross section is really not going to show us anything different than what we've already seen. We can take the cross section through, let's see. You can kind of get the leading edge of that front and see, where did it go? Aha. We can swing this back and forth. And it really doesn't really, show us anything different than what we saw with the volumetric scan from that. So very vertically structured cells with that Boeing segment. So, all right, well, that's all I have for our volumetric scans. Not really a whole lot to hone in on. No bookend vortices noticed. It's pretty straight. Pretty straightforward Boeing segment, but no tornadic activity that can be seen. So with that, thanks for listening.